Okay, today's lesson is going to focus on finding the perimeter of a semicircle. You're going to have in front of you the second page of the packet that you received for Chapter 8. At the top, it should say Perimeter of Composite Figures, Chapter 8, Section 2. We're going to be filling in example 1 as well as the on your own problems 1 and 2 together, and you'll be taking a picture of these notes and submitting it on Classroom. So make sure you're following along and copying it down as we go. Before we get into an example 1, I'd like to develop the formula a little bit. From last week, you could recall that when we found the circumference of a circle, or the distance around the circle, we multiplied pi times the diameter. And so if I think of a semicircle as half a circle, the curved part of the semicircle would be halfway around the circle. And so if I'm talking about the curved part, I could use the formula 1/2 pi d, because I'm multiplying pi times the diameter, but only taking half of that because it's halfway around the circle. But when you think of perimeter, you can think of tracing the shape with your finger and make sure you're going all the way around the shape. If I only do the curved part, I'm not representing this flat part down here, which represents the flat side or the diameter of the circle. And so I can't just use 1/2 pi d. I have to use that flat side as well. So the formula that we're going to use today for perimeter of a semicircle is that flat side, which is the same thing as the diameter, plus 1/2 pi d, which would give us the curved part. So take a look at example 1. They give us a semicircle. They tell us that that diameter, or the distance across the circle, is 6 meters. We're going to use that formula that we talked about, the side plus the semicircle, which is the same thing as the diameter, plus 1/2 pi d. Notice how in these first couple steps I can say P equals the formula. As soon as we substitute in 3.14 or 3 1400ths for pi, you'll notice my equal sign turns into an approximately equal to, or about equal to. So now its perimeter is about equal to the flat side, which is 6 meters, plus 1/2 times 3 1400ths times the diameter, which is also 6. So you'll notice when the diameter is given, we're using that 6 in two different places. One spot for the flat side, and one part for the formula that represents the diameter. If you wanted to plug this into your calculator using 5/10, you could multiply it as 5/10 times 3 1400ths times 6. But the important part is order of operations tells me to do this multiplication first. So whether you want to think of it as 1/2 or 5/10, go ahead and multiply those three numbers together, and you should get 9 42/100ths. So that curved part of the semicircle is 9 42/100ths. But I'm not back to where I started. I have to add that flat side, that's 6 meters. So 6 plus the 9 42/100ths gives me a total perimeter of 15 42/100ths meters. Notice how my label matches the label in the diagram. Okay, pause the video and try to do number 1 on your own using the example as a guide. You want to have the same number of steps that we have in the example. You're going to start with P equals side plus the semicircle, which is the same as D plus 1/2 pi d. And then think about what you would substitute in for the diameter in example 1. Hopefully you had a chance to finish number 1, and we'll go through that together. And then I want to talk about number 2 in the on your own problems. So in number 1, just like we did before, we start with P equals side plus the semicircle, which is the same as the diameter plus 1/2 pi d. When I substitute in the diameter, it would look like 3 plus 1/2 times 3 1400ths times 3. If you used 5/10, that's okay, but you multiply 1/2 times 3 1400ths times 3, and you should get 4 and 71 hundredths. That would represent the curved part. So the curved part's 4 and 71 hundredths, plus the flat side that's 3 feet, would be a total of 7 and 71 hundredths feet, would represent the perimeter. Now for number 2, you'll notice we're not given the distance across the circle. We're not given the diameter this time. So similar to what you did on the homework last week, you have to find what the diameter would be when you know the radius is 20 centimeters, or this distance from the center of the circle to the outer part of the circle. So if the radius is 20, I need to double that, and that means the diameter would be 40. So once I know the diameter is 40, I'm going to plug that into the formula the same way I did number 1. So P equals the side plus the semicircle, which is the same as the diameter, plus 1/2 pi d. In this case, 40 centimeters represents the side or the diameter, and it also represents the d in 1/2 pi d. So you should end up with 40 plus 1/2 times 3 and 14 hundredths times 40. And I go ahead and I multiply. Half of 40 is 20 times 3 and 14 hundredths would give me 62 and 8 tenths, would represent the curved part. When I add the flat side, which is 40 centimeters, I should get a total perimeter of 102 and 8 tenths centimeters. Don't forget your label. It should match the label in the problem. Okay, that concludes our notes for today. Go ahead and take a picture of your notes with either your phone or your computer. Insert that picture into the Google Doc in Google Classroom, and don't forget to submit the assignment. Please try to take a picture of your notes with the paper laying flat on a surface like your desk or a table. It's pretty difficult to read when you hold it up to the computer screen. And we will be returning any pictures that are too blurry to read. So please try to make sure it's legible. And then we'll continue practicing perimeter of semicircles tomorrow. Thank you.